In this example, we're going to look at how to use SPSS to create a multiple regression model of the relationship between education and father's education. So recall that in an earlier example, we looked at the simple regression of father's education as an independent variable and response education as a dependent variable. Well, what if we wanted to add more variables to the model? We could go to the Analyze pull-down menu and then go to Regression Linear. And here's where we can type in our variables. And so we have to pick our dependent variable first. And of course, that's the response education, which is just the variable educ. So we would find that, and we would move it up here to where it says dependent. And now we can put several independent variables in this space. And so our main independent variable of interest in this case is the father's education, or pa-educ. So we're going to move that over. And we can also put in other independent variables. So for example, let's suppose that we wanted to add age as a second independent variable. So what we're saying basically is that we think that father's education has an effect on response education independent of age. And so we can put age in here, and we can click OK. And SPSS will generate the regression results for this multiple regression equation. So here are some of the results. First, we can look at the R squared. This is a measure of model fit. And this tells us how much of the variation in the response education is explained by the combination of the father's education and the respondent's age. And here we see that it's about 22%. And so we can see that not a lot of the variation in response education is explained by the combination of those two variables, because there's still other variables that we need to account for that account for differences in people's education. It's not just age or father's education. There's also other things that we need to consider, which we don't consider here. In addition to that, we have some regression results down below. And so we can see that we have a regression slope for father's education, and we have a regression slope for the response education, and we have an intercept, or constant in this case. And so we can see that the effect for highest year of school completed for the father is 0.347. So how do we interpret that? Well, we can say that for a unit increase in father's education, that is every year increase, every additional year that the father has more education, we're predicting that the respondent gets about 0.35 more years of education. So a little over a third of a year of education, net of the respondent's age. And so we can see that age also has an effect. For every year increase in the respondent's age, we see that the education increases by 0.016 years, or a little over a tenth of a year of education for every year that someone gets older. Now, how do we interpret the intercept? Well, the intercept in this case, 9.146, that's going to be the predicted value of education for somebody whose highest year of school completed for their father is 0, and whose age is 0. And so they're predicted to have about 9 years of education. And so that's a bit of a nonsense result. Like, we wouldn't think somebody who's just born is going to have any education at all. But that number is going to change as we put in more variables. And so we might get some more meaningful results later. Advancing this video forward just a little bit, suppose that we thought that age actually didn't have a linear effect on education. So let's imagine that we thought that rather it had a curvilinear effect, such that as people get older, they get more education up to a point. And then maybe once that point is reached, education actually starts to decline. Because remember, we have some older people in our data set, and some of those people in historical periods before the present may have gotten lower levels of education overall. And so maybe we think that there's some kind of like an inverted U-shaped pattern between age and education. Well, we can actually incorporate that into a multiple regression model by using something called a squared term. So a squared term literally is the square of one of the variables, and it's a new term that we enter into the regression equation along with the main effect, and that helps us capture either a parabolic or an inverted U-shape response. And so to make a squared term, we would just go to this transform pull-down menu, and then we can choose compute variable. So let's make a new variable. Let's call it age squared. I'm going to use an underscore SQR to refer to square. So this is my new target variable. I'm going to write it right over here, and it's going to be equal to the value of age which I have to find, move over here, and I'm going to square it. So these two asterisks, this is what SPSS uses to create squared terms. And so I can just go down here to where it says OK, and I should now have a new variable in my data set that's equal to the square of age. And so if we just kind of go to Analyze, Descriptive Statistics, and then Frequencies, let's say that I just wanted to look at the value of age and age square in terms of just its descriptive statistics, like the average. Age square is going to be a new variable. That's at the end here. So if I click on statistics, let's say that I request like the median and the mean and the mode, the variance and the range and the standard deviation, the min and the max, I can sort of look at this new variable just to make sure I've created it correctly. Okay, and so here's some results from SPSS. So notice that the mode is the square of the mode of the main effect of age. So if I take age and square it, the mode here is 30. 30 squared is 900. And so you can also see that the minimum is the square of the new variable's minimum. The maximum is the square of the new variable's maximum. And so I've done this recode correctly. And so I can basically use this variable as a new regressor. And so again, if I just go to Analyze, Regression Linear, I can again put in my dependent variable, which again was education, and I can add my independent variables. And so remember that was father's education, and I need to find age again. We're also going to add age squared eventually. So here's age. I'm going to add that. And then my age square is my one at the end. We have to enter both of these together, and so the age effect will be captured by the combination of these two coefficients. So click OK, and then we'll kind of scroll down to see the results that SPSS has produced for us. Okay, and so we'll first take a look at our fit statistics, our R-square value. And we can see that that's a little bit bigger than it was in the last model. So rather than capturing 22% of the variation, we're now capturing about 23% of the variations. There's a slight improvement in model fit, but not a whole lot. Let's look at our actual results now of our regression coefficients. And so we can see that now the effect of father's education is a little bit different. Instead of about 0.35, it's about 0.34, but that hasn't changed a whole lot. We see that the main effect of age is 0.10, and then the square term has a negative coefficient on it. And so because the main effect is positive and the square term is negative, what happens here is that basically the main effect dominates the equation at low levels of age. But as we get into higher levels of age and the value of age becomes squared, that squared term's coefficient becomes more and more prominent in the calculation. And so what this is telling us basically is that the effect of age increases up to a point, and then it starts declining. And so what we're doing here is we're basically modeling an inverted U-shaped pattern. And so when you see this combination, a positive effect of age, a negative age squared term, that means that we have an inverted U-shaped function. Now, you could also get different results. It could be that the main effect of age is negative and the squared term is positive. Well, in that case, you would have a U-shaped function. And so basically, it would be negative up to a point, but then it would change to a positive relationship. But here we don't have that. We have an inverted U-shape. And then we can see again that the constants changed a little bit. Now it reflects somebody who has both an age of 0 and an age square of 0. But again, that's not very meaningful to talk about that, so we're going to kind of skip that a little bit. Advancing this video forward just a little bit more, suppose that we wanted to add more variables to our model. For example, let's say that we wanted to add a measure of sex to our model. Well, we have to actually change the coding of the variable a little bit, and we have to do that by creating a new variable. So let's look at the original coding of sex. We go to Utilities Variables, and we're going to find our variable sex. And you can see here that males are coded 1 and females are coded 2. Now, in regression, basically, there's two kinds of variables that we can use. Either continuous variables, like age, that are coded on some kind of continuum, or what are called dummy variables, that are coded 0 or 1. And so we basically have to take this variable, sex, which is coded 1 male and 2 female, and we have to recode it so that it's coded 1 and 0. Let's make one male the one category, and we'll call the new variable male. And we'll code females, who are now coded 2, into a new value, 0. And so we can just cancel out of this. And we're going to create a new variable basically by going to the transform pull-down menu. And we're going to recode the variable into a different variable. Now this is pretty important. We're not going to recode into the same variable, because recoding into the same variable will overwrite the existing variable, and then it'll be hard for us to ever recreate whatever we just did if we ever have to do it again. And so we're going to create a different variable. And so we're going to take the values of the old variable, in this case sex, and we're going to find that here in this space, and we're going to move it over. And we're going to create a new variable. We'll call it male. And we're going to call it recode of sex, male. And we'll click on change. That will put male as the destination variable here. So what we're doing is we're taking the old values of the variable sex and coding them into the new values of the new variable, male. And we're going to do that by clicking on old and new values. And so here's how the recode works. This is where you put the values of the old variable, and this is where you put the values of the new variable. And so we want the old value, 1, which remember was males, on the existing variable sex, to equal 1 of the new variable, male. And so we're going to put a 1 here and a 1 here. We're going to click add. Now we want females, who are coded 2 in the original variable, to equal 0 in the new variable. So I'm going to put a 2 here, I'm going to put a 0 here, and I'm going to click add. And then any other variable, which may be missing or don't know or something like that, I'm going to code that into system missing. So just put a little check next to this radio button for system missing, and click add, and then click continue. And if we click OK, we should have a new variable in our data set called male. And let's just make sure that we've coded that correctly. So one thing we could do is we can go to the Analyze pull-down menu, and we can look at the descriptive statistics for those two new variables, sex and male. Okay, so first we have to do is we have to find sex down here, and we'll move that over. Male is going to be at the bottom, so we can just kind of go to the end. And let's look at the frequency distribution, so make sure there's a check mark here. We'll click OK. And we'll look at the generated results from SPSS. And so we can see that in the original variable sex, there were 886 males, 1,088 females. And in the new variable, we have the 1 category, which of course is male, 886, so that matches. And the 0 category is 1,088, which also matches the number of women. So we've done the recode correctly. And so we can just basically add this variable into our regression equation. And so if we go up here to Analyze, Regression Linear, in addition to our independent variables, father's education, age, and age squared, we can add male. And so we'll just highlight male, move it over. It becomes another regressor in our model. And again, make sure you have the dependent variable education entered here. And we'll click OK, and we'll take a look at the results that SPSS comes up with. Okay, and so if we kind of zoom in here a little bit, we see again that the coefficient of father's education hasn't really changed much. Now it's like 0.344, which is what it was before. The main effect of age is still positive. The square term is still negative. But now we see that we have a slope effect for male. And basically that's a value of negative 0.232. Now how do we interpret that? Well, notice for one thing that we don't have an effect for both male and female. We only have an effect for male. And so that means that we're interpreting this coefficient in reference to the omitted category, female. So this is the effect of being male relative to being a woman. And so we can see that the value negative 0.23 means that women have slightly higher education on average than men. How much higher is it? Well, for men, their education is about 0.23 years lower. So a little under a quarter of a year of education lower. That is net of their age and their father's education. So women are a little bit more highly educated, which makes more sense because recently there have been more women entering the higher education market than there are men. And so we can see that net of their age and their father's education, women are just a slight bit more educated than men. Okay, so advancing this video forward just a little bit, suppose we wanted to add yet another variable. Let's suppose we wanted to add race as another predictor. And so let's assume that in addition to father's education, age, and sex, we also wanted to know if there's any kind of racial differences in education. And so let's look at the original coding of race. So if we go to utilities variables, we can find race here in our list of variables. And we can see that the race has the following coding. So 0 is inapplicable, 1 is white, 2 is black, and 3 is other. And so basically this is a nominal variable. And in order to use this in a regression, we have to take each of the different categories, white, black, and other, and we have to add them to a regression model using a series of dummy variables, each coded as 0 or 1. But like we did with sex, we can't use all three of the different categories. We have to leave one out as an omitted reference category, meaning that the results of these variables will be in reference to that omitted category. So we actually have to make 2 dummy variables, not 3. Inapplicable is not going to be used, obviously. So let's choose white as our reference category, meaning that we're going to make 2 variables, one for black race and another one for other race. And each of these is going to be coded as 1 or 0. And so to make these new variables, we're going to go back up to the transform pull-down menu. And again, we're going to make a new variable. That means we're going to recode into a different variable, so we don't overwrite the existing variable. And so let's get rid of our recode here. Let's take our variable race and make a new variable. And let's call that new variable black R for black race. And we're going to make a label that says recode of race, and let's call it black. And we'll click change, telling Spss that we're going to use the values of race to make the new values of the new variable black R. Now we have to tell Spss how to recode this, which values of the old variable are going to become which values of the new variable. And in order to do that, we're going to just click on old and new values. And so let's just clear out anything that was existing here so we don't get confused. Let's figure out how to do this recode. So here's where we put the values of the old variable that we're going to recode into values of the new variable. And so remember that blacks are coded 2 on the variable race. And we're going to code black people into a value of 1. And we're going to click add. And everybody else is going to be 0. So anybody who's white, who's currently coded 1, is going to be coded 0 in this new variable. But also people who are coded other, who were originally coded 3, are going to be coded 0 in the new variable. And so we're going to click add again, right? So any remaining values are going to be coded into system missing. So just put a little indication here in the radio button next to system missing and click add. And so what are we doing here? Basically, we're taking the old values 2, anybody who's coded black, and we're coding them as 1. And we're taking values of 1 and coding them to 0, values of 3 and coding them to 0. So this is whites and other. So when we make this new variable, we should have values of people who are black coded as 1, and people who are white or other coded as 0, and everything else is going to be missing. So we'll click continue and we'll click OK. And we can basically take a look at the descriptive statistics for this new variable. So if we just go to Analyze, Descriptive Statistics, Frequencies, let's take a look at the new variable race side by side with the new variable black R that we've created. And so just make sure there's a check mark here next to display frequency tables. When we take a look at the results, we should see that there's some parallels here. Okay, so you can see that we have 301 people in the original variable race that are black. And in the new variable, black R, we see that we have 301 people who are in the 1 category. So we've done that correctly. And so who's in the 0 category? Well, in the 0 category, we have 1,673 people. And then we can see basically here that we have 1,477 people who are white, 196 people who are other. And so if we add the others and the whites, it totals 1,673. And so basically the 0 category is everybody else but blacks. And so we've coded this correctly. Now we need to make one more variable for people who are in the other racial group. And so again, we're going to go to transform, recode into a different variable. And rather than recode it into a new variable called black R, let's call it other R. And we'll change the label a little bit. So it's a recode of race, but it's not going to be black. It's going to be other. And so again, we'll click change. that makes the old values of the existing variable race equal to the new values of the new variable other r. And we'll click old and new values. And again, let's just get rid of these just so we don't get confused. We'll kind of start over again. Let's figure out how to code this one. So remember that whites were coded 1 in the original variable. We're going to put them in the 0 category, and we'll click add. Blacks, which were coded 1 in the variable black r, for this variable we're going to make them 0. Remember they were coded 2 in the original variable race. So in the new variable other r, they're going to be coded 0. And so that means that people who are coded 3 for race, who are in the other category, we're going to code them as 1, and we're going to click add. And then everything else, basically, all other values, are going to be coded to system missing. And so let's look at the logic here. So basically, anybody who's white is going to be coded 0, anybody who's black is going to be coded 0, and then anybody who's in the other racial category is going to be coded 1, and everything else will be missing. So we'll click continue, we'll click OK. We should have a new variable now called other r. And let's just look at the descriptive statistics for that variable by going to the Analyze Descriptive Statistics Frequencies pull-down menu. Instead of looking at black r, well, we could keep it if we wanted to. We can use the new variable other r and make sure there's a check mark next to display frequency tables. We'll click OK. And we'll look at the SPSS results below. And so we see that for this variable other, there's 196 people in the 1 category, and that corresponds to the 196 people in the other category in the original variable race. And then the 0 category for that variable is 1,778, and that's actually equal to the sum of the 1,477 whites and 301 blacks. And so that means that we've recoded this correctly. And so now what we can do is we can just add those variables to our regression model. So again, if we go to Analyze, Regression Linear, in addition to the variables that we already have, father's education, age squared, and male, we're going to add those 2 race variables. So we're going to add black r and then other r. And again, our dependent variable is education. We'll click OK, and we'll get regression results basically for those new variables added to our model. And so SPSS produces our regression results. We can see that this model doesn't seem to have a much better improvement in fit. Our R-square is still about 0.23, indicating that the combination of these variables explains only 23% of the variation in response education. But looking down here, we can now see the effect of things like age and sex net of the effect of race. And so again, looks like father's education hasn't changed a whole lot. Still about a 0.34, 0.35 unit increase in the predicted value of education for every unit increase in father's education. We see that age hasn't changed a whole lot, so the main effect is still positive. The square term is still negative, meaning that we have an inverted U-shaped response. Sex is still negative and roughly the same value, meaning that women on average are a little bit more highly educated than men by about a quarter of a year. But now we have these new slope effects for black and other, and so we can interpret those in reference to the omitted category, which in this case is white. And so we can see that blacks, they have a slightly higher level of education than whites. So on average, in this sample, they have about 0.17 years of education more than whites. And then people who are other also have a negligibly higher level of education than whites, but it's pretty small. It's only about 0.02 years. So these things are very close to one another. We should probably also look at the statistical significance of these results now that we looked at these models. And so you can see that there's these t-values, which basically tell you how far away these sample results from what we think they should be in the population, assuming that all of these regression coefficients are equal to 0. And so these are significant values, or p-values, that tell us how likely these results are to happen by chance. So here what we're looking for is low values. And so let's say that we used a sort of a cutoff of about 5%. Anything that happens less than 5% of the time we say is not likely due to chance, but is a real result. And so you can see that the only significant results here are father's education, which has a very small p-value, age and age squared, which also have small p-values. But these values for sex and race are very large, meaning that these things can actually happen by chance quite a bit. And so even though we're seeing some difference between males and females, and blacks and whites and other, those aren't things that hold in the population. So these things can happen by chance too frequently. So they're not considered statistically significant. Okay, so as a final portion of this video, suppose we wanted to use PSPP to create some kind of a multiple regression model. Well, it turns out the PSPP has a lot of the same functionality as SPSS for making these sorts of regression equations. And so let's say that we wanted to create some new variables. Let's say that we wanted to start by creating a age square variable. Well, we can go to the transform compute pull-down menu, and we can make a new target variable called age square, which is basically just equal to age. And then here we have this x to the y indicating a radical or a power. And so we'll make age square equal to the square of age. We'll click OK. We can also create dummy variables. So let's say that we wanted to make a variable male to capture the effect of sex. We can go again to transform and recode it into a different variable. And so we're going to find our variable sex, move it over, and it should say sex under old. We'll highlight that, make a new variable called male, which would be the recode of sex, and we'll call that male. And we'll click change so that it knows to use the old values of sex for the new values of male. And then we'll click old and new values. And again, we're going to basically code men who are coded 1 on sex into the 1 value of male, so basically the same coding. And we'll click add, and then we'll click women who are 2 on the existing value of sex into 0 of the new variable male, and we'll click add. And then all other variables are going to code to system missing, and we'll click add. And so again, the logic here is that men who are coded 1 on sex are going to be equal to 1 on male, so that they have the same coding. Women who are coded 2 on the variable sex have a 0 coding for the new variable male, and then everything else is basically missing. And so we'll click continue, OK. We should have that new variable, and we could just use those variables in our regression model. Now I'm going to skip the coding for sex. That's also the same as it was in SPSS, just to save some time. And if we go to Analyze, Regression Linear, we can put in our values for our regression model. So remember that our dependent variable is education, our highest year of school completed. Father's education is our main independent variable of interest. Age was one of the variables that we added. We also want to add age square, which is here at the bottom. And then our recode of sex, which was male. And so we just want to make sure that we've got all our independent variables. We've got education for the father, age. We have the square term for age, and we have a value of male. And of course, we can also put in other variables like race if we recoded them. Anything else that we think might affect education net of these other factors. We can click OK. PSPP will create some results for us. And when we take a look at the results from PSPP, we can actually interpret them. And so, just like in SPSS, we have an R-square value of about 0.23, indicating that 23% of the variation in education is explained by the combination of these variables. We can see here that father's education has a slope effect of 0.34, indicating that for every unit increase in father's education, the respondent's education is predicted to increase by a little over a third of a year. We have a positive main effect of age. We have kind of a 0 value for age square, but I suspect that that's actually negative because it only gives you 2 digits. It really ought to give you more decimal places. It's probably negative. And so that indicates, again, a sort of an initial increase in education with age. It reaches a peak, and then it starts to decline. So what we have is basically a curvilinear effect of age. And then the effect for male basically shows us the same thing that we got in SPSS, a value of negative 0.23, indicating that men, on average, have lower education than women. And then if we look at these significance values, these are our p-values. And you can see that what's significant here is the main effect of father's education, the main effect of age, and its square term. Looks like male is actually not significant if we use a 0.05 cutoff. This tells us that there's about a 10% chance of finding a value of male that's equal to negative 0.23 if we assume that the value is 0 in the population. And so that's actually not significant, but everything else is. And so you can see that PSPP does pretty much just as well as SPSS in doing regression analysis, and each one of them is really appropriate. Either one of them could be used, and you'll get pretty much the same results.